Before we answer this question, let's recap how does the B field looks like, right, around a wire. So if you look at a more three-dimensional view, okay, you have a current carrying conductor. So the B fields, right, will be due to the current in a certain section will be these concentric rings, okay, the direction you use your right hand grip rule to predict. And these concentric rings, right, will be further and further from the previous one. Yeah, so if you look from the top view, right, you'll see current coming out and the concentric rings, right, the radius will increase. Yeah, so how do we represent, right, all of these, right, in a different way, which is, right, in a two-dimensional way. If the wire is like this, right, you consider along the on the plane that the wire lies on. So on the right hand side, right, you represent it by crosses, and because the concentric rings, right, get further and further apart, so these crosses, right, will end up becoming further away from the previous set of crosses. Same for the dots. Okay, therefore, right, if you have a wire loop, this wire loop, right, is being kept at a certain distance away and is moving parallel to the wire. Then, right, the flux linkage that it will have captured will have remained largely the same. Okay, whether is it here or whether is it here. The flux linkage, right, will be constant. Therefore, by Faraday's law, the induced EMF will be 0. So that's the answer B. Okay. An extension to this problem, right, would be what if the coil doesn't move upwards parallel to the wire but moves away. Okay, then what will happen? So you can consider this, pause a while and think what will happen. Yep, so if the wire coil actually move away from the wire, right, the number of arrows, right, sorry, the number of lines, right, going into the coil, which is a flux linkage, right, will decrease. So induced current will try to flow so as to prevent the oppose the decrease in the lines going into the page. So induced current, right, use your right hand grip rule, will try to flow in a clockwise manner. Okay, so this is a twist to this original question, and this is actually a common way of asking as well.